Hello my dear students, welcome back to our online class. Today I am going to explain about the motion of a center of mass. Motion of center of mass from the chapter Motion of a System of Particles and a Rigid Body. Motion of a System of Particles and a Rigid Body. The topic name is Motion of a Center of Mass. Right. What is meant by center of mass? Already explained in the previous classes. Okay, what is meant by center of mass? Right, the center of mass is nothing but the point at which the whole mass of the body appears to be act or supposed to be concentrated. Okay, the point at which the entire mass of the body supposed to be concentrated or appears to act is known as the center of mass. Center of mass, right? Suppose let us consider a rigid body and suppose it containing two particles of masses m1 and n2. Okay, actually the rigid body contains n number of particles. For our convenience, we consider only two particles in the rigid body, okay, whose masses is taken as m1 and m2, and their distances from the origin is taken as r1 and r2. Right? Here r1 and r2 are the position vector of the particle for particle 1 and particle 2. So position vector is a vector quantity. So it should be written in vector form. That is r1 vector and r2 vector are the position vector of the first particle and the second particle. The mass of the first particle is m1 and mass of the second particle is m2, and their distances from the origin are r1 vector and r2 vector. Right. Okay. Here what is the position vector of center of mass of the rigid body, rigid body which is containing only two particles, the position vector of center of mass is denoted by RCM vector, right? And it is given by summation of mi Ra vector divided by summation mi, right? RCM vector, the position vector of the center of mass, and it is given by the formula summation mi Ra vector divided by summation mi. But here this system containing only two particles. Okay, and for two particle the position vector of the system of rigid body which is containing only two particles is given by RCM vector is equal to m1 r1 vector plus m2 r2 vector divided by m1 plus m2, right? The position vector of center of mass of a rigid body which is containing only two particles of masses m1 and m2, and their position vectors are r1 vector and r2 vector is given by RCM vector is equal to m1 r1 vector plus m2 r2 vector divided by m1 plus m2. Suppose the system containing n number of particles, then their corresponding position vector of center of mass is given by RCM vector is equal to summation mi Ri vector divided by summation mi, or otherwise m1 r1 vector plus m2 r2 vector plus etc plus mn rn vector divided by m1 plus m2 plus etc plus mn, right? So if the system containing n number of particle and the position vector of center of mass is given by RCM vector is equal to summation mi Ri vector divided by summation mi, or otherwise m1 r1 vector plus m2 r2 vector plus etc plus mn rn vector divided by m1 plus m2 plus etc plus mn, or which is equal to, right, m1 r1 vector plus m2 r2 vector plus etc plus mn rn vector divided by capital M, right? Here capital M is equal to summation M. That is the sum of the masses of all the particles in the rigid body gives the total mass of the rigid body. The total mass of the rigid body, or M is equal to summation Mi or M1 plus M2 plus etc plus Mn. So the position vector of center of mass of a rigid body which containing n number of particles in it is given by RCM vector is equal to summation Mi Ri vector divided by summation Mi, or which is equal to m1 r1 vector plus m2 r2 vector plus etc plus mn rn vector. m1, m2 and mn are the masses of all the particles in the rigid body. R1 vector, R2 vector and up to Rn vector are the position vector of the individual particles in the rigid body. Individual particles in the rigid body, right? And this equation can also be written as m1 r1 vector plus m2 r2 vector plus etc plus mn rn vector divided by capital M. What is capital M? The total mass of the rigid body, or the total mass of all the particles in the rigid body. Okay, how can you calculate the total mass of all the particles in the rigid body? By adding the masses of each and every particles in the rigid body, we can get the total mass of the rigid body. So total mass of the rigid body is M, which is equal to summation of Mi, and which is equal to m1 plus m2 plus etc plus mn, right? So this equation gives the position vector of center of mass of a rigid body, right? If the system containing only two particles, then position vector of center of mass is RCM vector is equal to m1 r1 vector plus m2 r2 vector divided by m1 plus m2, m1 plus m2, right? Suppose these two particles are aligned exactly in the positive x-axis direction like this, right? The masses of the two particles are m1 and m2, and the distance of the first particle from the origin is x1 vector, and the distance of the second particle from the origin is taken as x2 vector, right? And the equation for x coordinate of center of mass is given by x cm vector is equal to m1 x1 vector plus m2 x2 vector divided by m1 plus m2, right? If the particle exactly lies on the positive x-axis direction, then the equation for x coordinate of center of mass is denoted by x cm vector. It is given by m1 x1 vector plus m2 x2 vector divided by m1 plus m2, right? Suppose the system containing n number of particles which are lying on the positive x-axis direction, then the equation for x coordinate of the center of mass is xm vector is equal to summation mi xi vector divided by summation mi. So these things are already discussed in the previous classes, right? So the equation for x coordinate of the center of mass is x cm vector is equal to summation mi xi vector divided by summation mi, or summation mi xi vector divided by capital M. Capital M, the total mass of the rigid body, right? And summation mi into xi, mi the mass of the all the particles in the rigid body. Here I value is taken as 1 to n. I value is taken as 1 to n, right? And this equation can also be written as m1 x1 vector plus m2 x2 vector plus m3 x3 vector plus etc. plus mn xn vector divided by capital M. So RCM vector is equal to summation mi RA vector divided by summation mi is the position vector of the center of mass of the system of a rigid body. But the equation for x coordinate of the center of mass is given by xm vector is equal to summation mi xi vector divided by summation mi. Right. Okay. Suppose if an external force is acting on the rigid body. Right. So whenever the external force is acting on a rigid body, suppose the rigid body starts to move. If the rigid body moves, automatically the center of mass also moves along the direction of motion of the body. Right? So whenever the rigid body moves, the center of mass of the body also moves along the direction of motion of the body. Right? If the moving condition is considered means it is necessary to deal with velocity and acceleration. If the rigid body is stationary, no need to discuss about velocity and acceleration. But if the rigid body under motion condition, it is necessary to deal about the velocity of the center of mass and the acceleration of center of mass. Right? How can you find out the velocity of a center of mass and the acceleration of the center of mass? Simple. By differentiate this position vector of a center of mass in 1 and 2 times, we can calculate what is the velocity of a center of mass and the acceleration of center of mass. By differentiate this position vector of a center of mass 1 time, we can get the velocity of a center of mass. Okay, by differentiate to 2 times, this position vector, we can get acceleration. Okay, so differentiate the position vector of a center of mass once and twice, we can calculate or we can determine the velocity of center of mass and the acceleration of center of mass. Right. Suppose let us assume the rigid body moves exactly along the positive x-axis direction. Then the equation for x coordinate of the center of mass is given by xcm vector is equal to summation mi xi vector divided by summation mi. Right? Here rigid body moves along the positive x-axis direction. If the rigid body moves along the positive x-axis direction, the center of mass of the rigid body also moves along the positive x-axis direction. Right? For that case, the equation for x coordinate of the center of mass is xcm vector is equal to summation mi xi vector divided by summation mi. Right? Already I told, if the center of mass moves along any one of the direction, it is necessary to find the velocity of the center of mass of the rigid body and the acceleration of the center of mass of the rigid body. Right? By differentiate to only 1 time, in this equation, we can calculate what is the velocity of a center of mass of the rigid body along the positive x-axis direction. Right? That is, the velocity of a center of mass along the positive x-axis direction is taken as VCM vector. So VCM vector is nothing but the velocity of center of mass of the rigid body. Right? Which is equal to the first derivative of the position vector of center of mass. That is d divided by dt of xcm vector. So by differentiate this xcm vector only 1 time, that gives the velocity of a center of mass along the positive x-axis direction. Right? Then VCM vector is equal to d divided by dt of xcm vector is equal to summation mi into xi vector divided by summation mi. Summation mi xi vector divided by summation mi. Right? Or VCM vector is equal to summation mi of d divided by dt of xi vector divided by summation mi, right? Or VCM vector is equal to summation mi into, okay, xi is a position vector. The rate of change of position vector is nothing but velocity. Okay, that is dxi vector divided by dt is equal to va vector. The rate of change of the rate of change of displacement is nothing but velocity, or a rate of change of position vector is nothing but velocity. Here dxi vector divided by dt is equal to va vector. So summation mi into va vector divided by summation m, right? Or m1 v1 vector plus m2 v2 vector plus etc. plus mn vn vector divided by summation mi. Summation mi is equal to capital M. Therefore, m1 v1 vector plus m2 v2 vector plus etc. plus mn vn vector divided by capital M. So this equation gives the velocity of center of mass of the rigid body, which is containing n number of particles, right? Next, the acceleration of center of mass, right? By differentiate this position vector with respect to time 2 times, we can get the acceleration. So differentiate this position vector with respect to time only 1 time, that gives the velocity of a center of mass. By differentiate to 2 times with respect to time, that gives acceleration of a center of mass. The acceleration of center of mass is denoted by ACM vector, which is equal to second derivative of position vector with respect to time is nothing but acceleration, right? So ACM vector is equal to d divided by dt square, right? D divided by dt of, okay, d divided by dt of xcm vector. So d divided by dt of xcm vector is equal to vcm vector. D divided by dt of xcm vector is equal to vcm vector. So therefore, ACM vector is equal to d divided by dt of, instead of d divided by dt into xcm vector is equal to vcm vector, right? Or ACM vector is equal to d divided by dt of vcm vector is equal to summation mi va vector divided by summation mi, right? The summation mi va vector divided by summation mi, or which is equal to summation mi of d va vector divided by dt. Okay, for our convenience, I am writing this equation, okay, in this manner: summation mi of d va vector divided by dt divided by summation mi, right? Here, rate of change of velocity is nothing but acceleration. Therefore, dva vector divided by dt is equal to ai vector. So therefore, ACM vector is equal to summation mi into ai vector divided by summation mi, or otherwise m1 a1 vector plus m2 a2 vector plus etc. plus mn an vector divided by summation mi is nothing but total mass. So this equation gives the acceleration of a center of mass. So acceleration of center of mass is given by summation mi ai vector divided by summation mi, or m1 a1 vector plus m2 a2 vector plus etc. plus mn an vector divided by capital M. So capital M is equal to summation mi. That is, capital M is nothing but the total mass of the rigid body. So to get the acceleration of a center of mass and the velocity of a center of mass, it is necessary to differentiate this the position vector of a center of mass in 1 time and 2 times with respect to time. And expression for the velocity of a center of mass VCM vector is equal to summation mi VA vector divided by summation mi. And the expression for the acceleration of a center of mass is ACM vector is equal to summation mi AI vector divided by summation mi. Right, the velocity of a center of mass of a rigid body VCM vector is equal to summation mi VA vector divided by summation mi. And acceleration of a center of mass is given by ACM vector is equal to summation mi AI vector divided by summation mi. Right. Suppose if there is no external force acting on a rigid body, there is no external force. That is, external force acting on a rigid body is 0. If there is no external force acting on a rigid body, the center of mass of the rigid body will not be affected. Okay? If there is no external force acting on a rigid body, the center of mass of the rigid body will not be affected. That is, the center of mass of the rigid body will in the state of rest or in uniform motion. Uniform motion. Right. Suppose when the center of mass is at rest, then the velocity of center of mass of the rigid body is 0. The velocity of the center of mass of the body is 0. If there is no external force acting on the rigid body, the position of the center of mass of the rigid body will not be affected. It means the center of mass will remain in the state of rest or otherwise in uniform motion. Suppose if the center of mass of the rigid body is at rest, then the velocity of the center of mass of the rigid body becomes 0. Okay? So VCM vector is equal to 0 or a summation mi VI vector divided by summation mi is equal to 0. Right. Suppose if the center of mass of the body has uniform motion. If the center of mass of the rigid body has uniform motion, then the velocity of the center of mass of the body is always a constant. So VCM vector is equal to constant or summation mi VA vector divided by summation mi is equal to constant. Okay. Even if there is no external force acting on the rigid body may be in the state of rest or otherwise it undergoes uniform motion. If the center of mass of the rigid body is at rest, then its velocity becomes 0. That is, the velocity of the center of mass value becomes 0. Suppose if the rigid body moving with constant velocity, or suppose it undergoes uniform motion, then the velocity of the center of mass value is constant. Velocity of center of mass value is constant. Right. In both cases, the acceleration of the center of mass of the body is 0. Even the center of mass is at rest or the center of mass has uniform motion, the velocity value may be 0 or constant. But the acceleration of a center of mass in both situations is 0. Okay. So these conditions are applicable only if there is no external force acting on the rigid body. If there is no external force acting on the rigid body, the velocity of a center of mass may be 0 or constant. But the acceleration of a center of mass value is always 0. Right. Even there is no external force acting on the rigid body, but the particles in the rigid body may move with their respective velocities and respective acceleration in various directions. Okay, so the particles has definite velocity and acceleration inside the rigid body. Okay, so that velocity and accelerations are due to the internal force exist within the rigid body. So due to the internal force exist within the rigid body, the particles in the rigid body is moves with their respective velocity and acceleration. But the velocity, the center velocity of a center of mass value may be 0 or constant if there is no external force acting on the rigid body. But the acceleration of a center of mass value is always 0. But due to the internal forces, the particle has velocity and as well as acceleration. Okay, so velocity and acceleration, experienced by the particle is due to internal force. But if there is no external force, the velocity of a center of mass value may be 0 or constant. But the acceleration of a center of mass of the rigid body is always 0. Right. Suppose there is a external force acting on a rigid body. Say external force is not equal to 0. It means external force acting on the rigid body. If the external force is acting on a rigid body, then the rigid body gets accelerates. The rigid body gets accelerates. From Newton's second law of motion, F is equal to ma. Here external force, F external vector is equal to summation mi into acceleration of a center of mass is ACM vector. Right? If external force acting on a rigid body, the rigid body gets accelerates. From Newton's second law, F is equal to ma. Okay, so external force is equal to summation mi, that is the total mass of the rigid body, into the acceleration of a center of mass. So summation of mi is taken as m. Therefore, external force is equal to m into ACM vector. Therefore, acceleration of a center of mass is given by F external vector divided by em. So this equation also gives the acceleration of a center of mass. Right? If you know the masses of all the particles in the rigid body and their respective accelerations, then we can calculate the acceleration of a center of mass of the rigid body by using the formula ACM vector is equal to summation mi AA vector divided by summation mi. Suppose if the magnitude of external force acting on the rigid body and the total mass of the rigid body, okay, the acceleration of a center of mass can also be calculated by using the formula ACM vector is equal to F external vector divided by em. And the velocity of a center of mass is given by VCM vector is equal to summation mi VA vector divided by summation mi. If there is no external force acting on the rigid body, the velocity of center of mass value may be 0 or constant, but acceleration value 0. If external force acting on the rigid body, the body experiences an acceleration. The center of acceleration of a center of mass is given by ACM vector is equal to F external vector divided by em. So this is for about the motion of a center of mass. Right. Thank you, student. We will see in the next class.